Have you ever looked at a math problem and just thought, how would I even work this backward? Well, today we're diving into exactly that, the really elegant idea of inverse functions, which are basically the mathematical equivalent of hitting the undo button. Okay, let's just jump right in with a real-world puzzle. Picture this, a big conical mound of gravel. We know exactly how much space it takes up, its volume, but what we need to figure out is its radius. So, where do you even start with that? This is what we call a classic reverse problem. We know the final result, the volume, and our job is to work backward to find the initial cause, the radius. And this kind of thinking isn't just for math class, it's a core challenge in science, in engineering, even in detective work. So, to crack a reverse problem like this, we need a special kind of tool. We need a way to mathematically unwind or undo that volume formula. And that amazing tool, as you might have guessed, is called an inverse function. So what exactly is an inverse function? Well, it's actually beautifully simple. It's a function that does exactly what it sounds like. It reverses or undoes another one. Think of it like this. If you put A into a machine and it spits out B, the inverse function is what lets you stick B right back in and get your original A back out. It means the inputs and outputs completely swap jobs. Now, what's really wild is how simple this is at its core. OpenStax just nails it here. All you have to do is interchange the coordinates. In other words, you just swap the input and the output. That's it. Take a look at this table. It makes it super clear. In the original function, an input of 0 gives you an output of 5. Now, look over at the inverse function, an input of 5 gives you an output of 0. See that pattern? The x and y values are literally just trading places. 1 becomes 6, so in the inverse, 6 becomes 1. It's that straightforward. Okay, hold on. Before we go any further, I have to give you a super important warning. That little -1 you see in the notation, f of 1x, that is not a negative exponent. I'm going to say it again. It is not the same as 1 over f of x. It's just the special symbol that means inverse. Don't fall for that one. It's a really common mistake. So, now that we know the proper way to write it, there's another vital detail. You see, it'd be great if we could just hit undo on any old function, but there's a catch. Not every function can have a simple inverse. It has to play by a very specific rule. And that rule is called the one-to-one rule. For a function to have a true proper inverse, every single output can only be connected to one, and only one, input. No two inputs can ever lead to the same output. It has to be a unique pairing, a perfect match, every time. Now that might sound a little technical, but lucky for us, there's a super easy, visual way to check for this. It's called the horizontal line test. And this slide just lays it out perfectly. If you can draw a horizontal line anywhere on a function's graph and it only ever crosses that graph once, congrats, it passes the test. It's 1-to-1. But then you look at something like the parabola on the right. A horizontal line can hit it in 2 spots. That means 2 different inputs are giving you the same output. It fails the test. This brings up a pretty big question, right? Parabolas are everywhere in physics and engineering. They're incredibly useful. So if they aren't 1-to-1, how in the world do we find their inverse?
Well, let's get into it, because as it turns out, mathematicians came up with a very clever workaround for this exact problem.
And the solution is kind of genius in its simplicity. You just restrict the domain. In other words, if the whole function doesn't pass the test, hey, no problem. Just use a piece of it that does. If we go back to our parabola, y equals x squared, but this time we make a new rule. We're only going to look at the right half, where x is 0 or greater. Well, all of a sudden, it passes the horizontal line test. By just narrowing our focus, we've made the function invertible. How cool is that? Okay, so now we know we can make a function invertible. How do we actually find its inverse using algebra? Well, it's a pretty straightforward 4-step recipe. First, replace f of x with y. Second, and this is the big move, you physically swap the x and y variables. Third, you just use your algebra skills to solve for the new y. And finally, you give that y its proper name, f inverse of x, to show everyone it's the inverse.
And here's where it gets really cool. When you follow those steps for a quadratic function like x squared, you discover something amazing. Its inverse is a square root function. This is a huge aha moment. Squaring something and taking its square root, they are literally 2 sides of the same mathematical coin. They perfectly undo each other. So, now we have all the tools we need. We can finally apply this knowledge and go all the way back to solve our original, real-world problem.
Let's revisit that gravel cone. We know the volume is 100 cubic feet. We've got the formula that connects that volume to the radius. Our mission is simple. Find that radius, r. By applying those algebraic steps we just learned, we can find the inverse of the volume formula. And what we get is this powerful new formula, one that solves for the radius if we already know the volume. This is our undo formula, custom built for this very problem.
The hard work is officially done. Now we just have to plug in the numbers we know. We substitute 100 for v and about 3.14 for pi.
And when we run the calculation, we get our answer. The radius of that gravel cone is about 3.63 feet. We successfully worked the entire problem in reverse. So what's the big takeaway here? Inverse functions aren't just some abstract concept from a textbook. They are a genuinely powerful, practical tool for working backward, for starting with a final result and figuring out exactly what caused it.
And that leaves us with a final question for you. Now that you have this new way of thinking, this working backward mindset, what other reverse problems can you spot out there in the world? In your job, in science, or even just in your daily life? I have a feeling you're going to start seeing them everywhere.